We're back again with another video. After a long time, we'll be doing certain lab assignments in C, and I am doing this because I like coding in C and also because I wanted to use C line. So yeah, let's see what happens. Let's get started. Just close my camera and yeah, let's go. So bit of context. This is what the assignment is. It's pretty much making this structured person and essentially implementing min and max heap and doing these operations. So this is what I've done so far, right? And you have to read this from a from a text file, right? And oh my God, I just okay, right. So it will contain basically the age. So this is age, weight, and height. I think height, weight. Okay. Anyhow, so let's see what I have. Let's see what it is. So number of students I've defined as 5. Interesting. Read student from the source file and what do you mean const add const. Okay. And then we return null over here. What does this mean? Acha, null pointer. What are these codes, bro? So think anyhow, chill. So this is just so this function, just make sure this is still running. Acha, no, just change that for null, to be honest. At that point, just change it for null, right? Acha. So the first thing we have to do. This is my first time using C line, by the way, chat. So we are reading the students from the source file. You're opening the file and just opening the file. If it's null, return null, and then we malloc bunch of students. Number of students. I mean, to be honest, do we need to malloc a number of students because we know it's fixed, right? It's like we can always do something like percent students. Like it just. I mean, okay. I mean, yeah, it's fine, I guess. Again, we are creating a temporary buffer, putting that into the buffer, and then closing it. And this is just for swiping between two person variables, as you can see. And this is our build heap and maxify. So let's try to see what the code is. So let's build max heap. We have a person array and we have the index. It's funny because acha, so one thing I want to do is we would actually acha, let's see what happens over here. So case one read data. So this is reads that data, tells us that data in that way. Obviously we're freeing data, and this is just the not the right way to do this, if I am correct. The color theme is hitting me in the eyes. How do I like change it? Can we have monokai, bro? It's actually hurting me in the eyes. Mono. What is it? Mono. Yeah, okay, this is much better. I don't know, for some reason, even when like, sorry man, the color thing does matter. For some reason, it was hurting my eyes. For some reason, it's just crazy. Anyhow, okay, so let's see once the code is right. I would like to go ahead and do that. Other menu choices are similarly verified. Acha. Um, I like how these people say non-increasing order. Just say decreasing order, bro. No one is gonna die. No one is gonna die if you say that. Acha, cool. Uh, Baap re baap, C-line is not responding. This is the thing of using a proper ITE. The thing with VS Code is just lighter. I'm trying to do shift templates. Acha, I can't even move. Acha, no worries. theme. This is what I want. Acha, this is perfect. Also, what is the font over here? What is the font? The font. What font are we working? Cascade. Are you guys for real, bro? Oh, hell no. Anyhow, okay. This is our struct. I think one better way. So let's really see if the code is right. So we do min heapify, and this is the index. Let me just change this to I for better simplicity. Um, okay. Acha, and if this is not equal, then you swipe that. Okay. And actually, one thing we have this over here. We have length, size of. Right, we have some that, and this will be actually just pointed to the heap. Right. अच्छा इसमें problem क्या है कि this will be another the size of because it just standards it right इतना बेचारा size of heap right, that's much better um and over here when I why is it build min-heap s2 build min-heap this is and heap and this will be size of heap right so size of heap and this will be just heap over here and again we have size of heap so that is much better and case to get the same number of students right so that shouldn't cause any errors as per now if I'm correct. I'm sorry I'm going slow right now because I just want to see if things are working or not. This error code, what's the error code? Acha wait okay let's see where the error is 49 where is the issue? Acha my bad. Acha error build min-heap 152 acha 152 में error है it's over here I think it's much better to have it but it's hidden there so number of students right we do make min works great so acha great should I really care about freeing them at the moment I mean sure can you make something like void free heap so you can say person heap and you can oh wow how do I auto complete that tab okay this is fine um uh to be honest I don't want to do that there's a good reason behind that because I don't want to learn so we'll just do free heap and we will say so how do we want to free this we'll say for int I is equal to 0 I less than size of the heap what do we want to do right now so each heap element so each heap just contains that read student and this read student gives me a person star which is essentially just this with a person and this might yeah so that will be not free but that will obviously have something there so I could always say um, So that is there. Can you stop? Can you can you I don't need this autocomplete. Auto. Okay, thank you. So over here we'll just do um, free the heap and wait. So this will just free the name. And so now I just have to do free the heap and I just give students. Actually, wait a minute. It, uh, I think I'm doing something wrong. Hindsight, yeah. If I just make this actually work. Acha, and now because this is acha caps lock on. So now because this is working, I could just right build max heap and I can just paste it over here. Free heap s4 number of students. I hate that, but I'm doing that for a reason. Weight of the youngest person. The 4 wala kya hai? Display the weight of the youngest person. Weight of the youngest person is that. Acha, I am doing it over here. Okay. Acha, what's the issue over here? Clanked ID switch has two consecutive identical branches. Acha, what do you want me to do? My bad. So it will basically act like that. Acha, oh wow, double free directed in cache. This is based on the one wala. I don't know. Oh, I have double. Double free directed फिर से कर रहा हूँ क्या मैं? Man, I was trying to be so chill. Sorry, my double free. Yeah, I had accounted for that. Maybe. Yeah, now to this one really double. Sorry. That is fine. Weight of the youngest person, and so now we'll have few other things. Also, let me just look at the code. Build maxi को अभी के लिए छोड़ देते हैं, but ठीक है, we'll change this. But this will be and this will be the size of and I'll move that. This will be size of this will be the heap and this will be size of um, um, heap heap size of heap righty um, and यहाँ पे will also have size of and largest cause यहाँ पे smallest so यहाँ पे largest आएगा and this will be size of चलो ठीक है so I'm hoping this works 140 हाँ my bad implement भी तो हो रहा था number of students yeah so ठीक है fine make main 1 2 3 4 5 चलो ठीक है with that out of the way, we can add extra things that we wanted to do, that such as to insert a new position into the main. So let's add um, insert a new person into the min heap, right? And printf. Actually, no, I'm not doing like that. 6 delete the oldest person, and then finally 7 would be exit. Achha, yeah, so I see it. So let's think about this. So we are doing all of this. We're going to insert a new position into. I'm thinking of making all the heaps over here at once. So we build the, so we did obviously we create again. So we're just creating it over here, right? And we display the weight of the person. So we can do that. Insert a new position. Acha, I think um let me do this. Let's take this position out, okay, and let's put it over here. ठीक है, right? इसको कर देते हैं वहाँ पे. Okay, and इसको हम लोग पेस्ट कर देते हैं. अरे यार, fuck it, you're overthinking it. Okay, you're too much overthinking it. Over the box. What's the issue? What? Why I want to add static for now? Don't worry. So display the weight of the youngest person. That has been done. One, two, three, four. Also, we just do val kind. Okay, so we have no freeze. Let's go GG's. Acha, so now we have to insert a new position into the min heap. Acha, so now to insert a new position into the min heap. Delete the oldest person. So I think what we can do is a extract oldest, and we can do person star heap. We need to do that as that sounds size of heap, and let me say it will just delete the oldest person. Yeah, I mean delete the oldest person. And so what this is supposed to do is it's supposed to do exactly, so what it's supposed to do, for example, we have a bunch of heap, right? Imagine we have a heap over here. All we want to do is we want to remove this. We just put 2 over here and we remove this. So we remove this at all from our heap, and then we apply we apply maxify, I think, not build max, we apply max heapify on this. Right, so how would you want to do that? The very first thing I would like to do is I would like to do something like heap 0 is equal to heap size of heap minus 1, something like that, right? If you actually think about it. So what you're going to do is, so the size of the heap is like 5, so the last element will be 4, right? So the fourth element becomes whatever the first element is, right? And then make the heap to the size of minus 1, right? Because we want to do that, we don't want that garbage ID to be on the other side, right? So how do we do that? We get a person and we are returning void. How can we do that? I mean, one thing that the thing is the now the size of the heap will just keep on changing. In that case, right? Like it's gonna just keep changing, and that's gonna be the issue for us if we have to delete the oldest person. Acha, that's gonna be an issue. The thing is, I could most probably do some pointer arithmetic and make this point to a new heap. But then this will update, right? But at the moment, this is just a fixed value on top, which is not exactly what I want it to be, right? So just I'm thinking like, how do I now make it so that it works? Hmm. So how do I make this work? Okay, let's make this let's make this int. So I know what to do. So returns the length of the new. Okay. Okay, now let's make the new loop. So we'll say something like we'll say person star new is equal to person star malloc size of person into size of heap minus one, right? That's the very first thing we do. The issue tag can be replaced. What I don't want to do that though. Acha, so we have this, right? So I would just want to first thing I want to do is I want to do for int I equal to 0, I less than size of heap minus size of heap. So अभी के लिए क्या हुआ? अभी के लिए this अभी के लिए where is this alpha? So this happened, right? मतलब we don't want to this happened include this. So now this if this is 1 5 6 6 1 2 6 minus 1 is 3 0 1 2 3 4 5. So yeah, less than that I plus plus, right? Then we say new heap I is equal to heap of this, right? Acha, then I will say free wherever heap is, and then give heap to be equal to new heap. Okay, heap is a problem. It's not returning right. And then we just return size of heap because with one will be less minus one. Acha, so this is pretty much free I size of this new heap is equal to heap minus one. Then I will say max heapify. No, not that. I want to called max heapify. Max heapify. On heapify heap size of heap minus one and index 0. Acha, this should work. Acha, so let's see if there's any issue. Extract oldest, what's the issue? Can we set it to okay, that is not an issue. Okay, hopefully this works. Let me see what's happening. So heap is equal to size of heap minus one. Okay. Person is equal to new person. Person malloc size of person to this. Okay. Int I is equal to this. I less than size of heap minus one. I plus plus. New heap is equal to heap I. We free that heap. Don't need that anymore. Right. And then we do heap is equal to the new heap value. Max heapify. And then we do that. Okay. This is for 6. Delete the oldest person. So if I make a case 6 case 6 and also this will break person s6. I don't like why I'm dictating most of them, but why are we reading it multiple times? Acha, man, that's just crazy. This is so bad code. Don't write this code, chat. This is just bad code. This is some bad level code. Trust me, this is some bad level code. Um, इसको S6 कर देते हैं. S6. I think we'll build Max-Heap S6. ठीक है. And it's not S6. Right, so this is here we're gonna have size. We're gonna say size len of heap. Okay, ठीक है len of heap. Initially it will be number of students, right? But this will change. So if I want to build the heap, I would say len of heap se banana, and this will also be length of heap, right? We want to delete the so we would say extract oldest. So we'll say over here we would say something like length of heap extract oldest S6 size of heap len of heap. Okay, chat, let's see if this works. अच्छा 5 में रुक जाता है. 6. Okay, segmentation for code dumped. Okay, val grind अच्छा, so this is fine. How does free heap work? Free heap goes into the size of heap and we say free heap, free this heap only. Okay, ठीक है, कुछ ज़्यादा कुछ खास नहीं. अच्छा, then how does extract oldest work? Extract oldest heap is equal. अरे I'm such a dumb. I am such a dumb. Let's say something like no, that doesn't work, right? Yeah, अब heap ये है. Heap 0 is equal to heap of size 1 is 1 था. Person new heap is equal to person malloc size of person malloc need one less, right? I plus plus new heap is equal to heap I. So we change that. We feed I. We give heap this new heap function, and then I just say maxify heap of size of heap minus 1 0. I don't know what I'm doing wrong on this. What is actually the algorithm for removing the oldest? I mean, is this comparing over here and then going down, right? Extract max priority queue from Max-Heap algorithm. I mean, I bet that's what the algorithm is, right? We say that and we just apply. I mean, ठीक है. Place with the root element. ठीक है. Max heapify there, yeah. So I am doing max heapify on index 0 where I want to do that, and then this returns size of heap minus 1 as on that. What's the issue over here that we're facing is we have person students and length is that. So what does student do? It's reading a number of floor. It's just this code is so badly written and it's written by me, so that makes me more embarrassed by it. And then we do length. We just do extract oldest, right? Acha, my bad. I know what I did wrong. We want to change that, right? Well, we have to do this actually. We have to do this actually. So yeah, so because you change the heap itself, right? You'll explain what I'm trying to say. So now, so okay, this is where it gets a bit nitty. I have to make. So let's say this is heap, like it's a heap value. How do I write this? So let's say the actual value of heap is somewhere stored at 1,000 memory address. This itself contains some memory address for the starting base address. So the first level pointer would be just having 1,000, having 1,000. Right? We can go access this, right? Now this is itself a pointer. Now we are having pointer to a pointer, so we can access this now, right? We can access this, and then pointing this, we can access that, right? And so now we have to what we have to do is something like heap. I want to go to that, so I want to so from here I want you to access this. We have 200, and we have 0 is equal to heap. Access that size of heap minus 1. Okay, this works, and we do new heap, and then we will say over here, we will say heap of I. Okay, then we will say free heap. So it will say it will go over here and this है क्या लोकेशन 2000 वहाँ फ्री कर दो and यहाँ पे give this as the new and heapify this is the new and down here we will give the address of S6 as the value over here. Uh, not over here, my bad. We have to give this where this is stored. So extract oldest. So this will now extract person heap. Okay, we're changing the heap. That's where we. Okay, this should work. I have a very good feeling that this might work. Let's change few things. Make name. Oh, hi. Free invalid pointer. Acha, free invalid. I think I'm doing something wrong. Extract oldest. So person star star. Okay, why am I still doing that? कुछ तो मैंने memory का छोड़ दिया. Oh, it didn't. Oh my god, it worked. Val grind. Let's see. Uh, so we had 11 allocs and 10 frees. Got it. So here we're doing is like heap, free heap. This one's the application, so we'll give it that, and this one's the size of it. I mean, technically, size of this is size of the heap at the moment, right? अभी तक तो वही है. Right now it will be that only. 15 frees. But if you're giving me this, right, I'm doing a bunch of this shenanigans, and I'm saying new. I'm saying that I'm doing free heap size of heap. Sure, I don't know what's happening. 15 free, something is going wrong. Free heap. Somewhat working right now. Okay, that's not bad. I wouldn't say that's bad. We can work on that. One less fee. Also need to do something like len of heap became 4. technically 20 array shifts increasing by a factor of 2. Sure. Memory becoming 2. Why do I think memory location there? Because I run everything else. 1, 2, 3, 4, 5. So everything is fine, but here that's the issue. So you work on that. Insert a new position into the main heap. Brother, insert position. Yeah. Okay, let's. This is just exhausting, bro. How do I even add a new over here? Okay, let me do some simple examples then. Let's close this. Right, let's close this for now. Let me see if I could do a simple example. So let me have uh alright, let's have something like let's have something like this. So let's keep this very simple. I'm gonna do something very simple. I think there was a thing I did for this standard h. Let's have this very simple thing where I have, let's say, I will have a heap of like 10 elements. I mean, this is being dynamically made. Okay, let's not think that probably. Let's have a 5, I guess, randomly assorted. So 5, 4, 3, 1, and our job is like do that. So let's build mapping. So let's just do something like min heapify, and the first thing we'll do, we'll have an array to that, and we'll have something like size, um, length, and the I you want to start from, right? Min heapify. And so one thing we'll do is int smallest is equal to I, int left is equal to, how to left is 2 into I plus 1, do I remember that? And if I do right, that would be 2 into I minus 1. And that's not my bad, what am I saying? Plus 2. Let's see if that works. So I is 0, so 0 into that is plus 1, and so that works. 2 if statements will be here. We don't need this. So it's much more. If left is less than length, and heap of length, so heap of left again is this min heapify is less than the heap of the smallest, then I want you to tell me, I want you to become the smallest. I want the smallest to become of left. Okay, take this right, right, right. So right, that makes sense. So if right is less than 10 and heap of right is less than heap of smallest, technically in a min heap it is acceptable for the parent of I to be less than or equal to child of I. So but over here I'm assuming it's all distinct, so we don't really cater to that. Right. Now only if also we need to make a swipe function, so we'll say void swipe in star a in star b in temp is equal to star a star b temp. अच्छा, so ये हो गया. अच्छा, so now what will we say? If what was the thing? If smallest is not equal to I, we will say swipe जो भी smallest था with heap of अभी का, and then we'll say min heapify on the same heap of the same length, but here we want to go down to the smallest route. And this is a very simple example of what this is all about. Right, if I have a very simple example, I'll show you like one over here. So this, what does that look like? It look like something like this: 5, 4, and 3. So after this is done, this should look like 3, 4, 5. Like min heapify, and I'll say heap kind of something like this: size of heap by size of heap this, and we'll say 0. Right, let's ls, sorry. And if I do something like I less than 3 plus if, so as you say 3, 4, 5, this kind of works. How do we build it? So now we can say void build min-heap. It's very much easy. You can say in star heap, so we'll have access to the heap, length of that heap, and that's all. So now what we'll say for int j is equal to length, कितना कुछ तो होता है यहाँ पे, we'll write this later, j minus minus, and we'll do something over here. We'll do that. So how does that work? Essentially, we want to find out the last parent. So over here, if we number this 0, 1, 2, 3, 4, 5. Now, technically, our last parent is 6. So how do we find 6? We do 0 by 2. That's weird. That wouldn't really work. Now this is our last parent. So if I do 0, 1, 2. I think I'm missing out something in here. So 2, 3, 4, 5, 6, 7. So total 8 elements is 7. So उसमें से 3 is the largest. Now pay 4, and if I do minus 1, I get 3. So based on that pattern alone, I can say length is equal to minus 1. And we want to continue this up until that. So while j is greater than equal to 0, and you will say min heapify the heap with the same length with j, and this will essentially sort this. So if I show this to you, and if what's the issue, build min heap algorithm in C, we actually search for this. As you can see, this is the min heapify. See, build mapping I size to I greater than, and that is what it is, right? That's great. So that means our things was right. Now, if I have a proper, let's say 10, 9, actually 5 is a 10, keep it small for now. 5, 4, 3, 3, 1. Acha, so now we'll do min, we'll say build min heap, and length, so as is length is equals, तो एक बार लिखूंगा, I want to like do it again, so size of, right, 1, 2, 3, 4. Okay, interesting. Why does it work like that? 1, 2, 3. Acha. So let's see what might have happened. This is our this, so 5, 4, 3, 2, 1. So let's index them. 0, 2, 3, 4. So it's 5 by 2, 2 minus 1, 1. So we will start from here somewhere. So we would have started somewhere from min 55 of the heap of size 5 on 1. So if we are on done on 1, you would have seen keep. Let's check this, right? So left is less than the smallest. I mean, you can think of smallest as being the parent in this case. Um, if smallest is not equal to I, swipe smallest with I and again, so it will say, so it will, okay, so right now it was 4 to 1. 4 to 1, so it will become 1, 2, 4. Right, and this will go from 1, go from 1. Actually, because it started on 1, then go to 0. So 1, does 1 satisfy the condition? Yes, it does. Right, comes over here and it then goes over by 0. Yeah. Acha, then we'll come to 0. 5 will compare with these of them. Acha, interesting. Top down approach, sorry. Oh no, yeah, I mean this kind of makes sense. Put this back, this will be 1. Something is wrong. Anyhow. Acha, so now let's think about how will we add. Okay. Okay, let's do this. Extract min. So let's say, I mean this will be in star heap. So what I want to say over here is, okay, what is a heap? Heap से कुछ भी location में. This actually contains an address to the array. This is itself a pointer. Now we will have somewhere over here another pointer. So what this says, we'll have a pointer to a pointer, right? And what does that mean? The very first thing we will do is if length is less than or equal to 0, we will just return 1. I mean, we will return -1, right? If length is less than. The thing being that if length is greater than, yeah, so else what we might do is we want to actually do something like heap 0, right? So how we can do that is we can say heap, you wanna do it actually, I wanna indent it, came back to over here. 0 will be equal to whatever is equal to length -1. That should make sense, right? This is equal to that, and also um, min value is equal to and I'll just say over here return min value. Okay, इसका है int min value क्या लिखा ना, extract min value. Extract min is, so we do this of this and we do length. Does that work? Now let's see. अच्छा, इसमें इशू क्या है? Incomplete product type. अच्छा. Okay, let's do something like in star is equal to in star malloc size of in into 5. Yeah. 0 equal to 4. अब इसमें प्रॉब्लम क्या है? इसके वजह से and this will work actually. So 1, 2, 3, 4. Again, this is not most ideal way of doing this, but this is just to get my thing across, right? Extract min. So we're pretty much putting that value. So we want the value of what? We want the value of 1000 somewhere. So that is what we're doing there. And if I make t from t, the min value will be that. That works. And this is what happens. So now, if funny thing, if I do something like print f, if I print heap 0, now it will be some different value. It will be 4. Not that interesting, but just something to keep in mind, right? So this happened. Also, one more thing, I wanna the end will just be free. Right now, what I wanna do is we want to make a new like heap. So we'll say something like in star new heap, and this heap will be in star malloc size of in into length -1. Okay, that will be our new heap, right? And we have done this, and we'll say for int I is equal to 0, I less than length -1, I plus plus, and यहाँ पे new heap का I will be equal to heap का I, right? So that is something that no, this is here that's a mistake. So I'll say intent then I, right? Okay, right? And so that happens pretty much. And then what we will do, then I want to do min-Heap on the new heap of size length n-1 on 0. Acha. Now if I make this, okay, maybe one while grind. Again, this is some issues happening. So now my length is a bit decremented. This is my new. This is return value. I am mallocing this. I am doing this also, but because I'm doing extract min, this value has been a bit less decremented. So I am allocking a lot, but I'm not doing that much. Acha, so how do I do that? Why is it being an issue? Movie install malloc. Acha. Then I will say heap. So first thing we'll do, we'll free that purana wala, right? And then we'll say heap is equal to new heap, and this will be the heap. That should fix it. Okay, now it works. Choose value what I was doing, right? Okay. Acha, so until we do this, so let me see if I do this how many times. So acha, wow, that's something you want. Something is happening. 0 कहाँ से return हो रहा है? So int min value is is whatever is in the 0th index, and then replace the 0th index. Length is changing, right? So यहाँ पे length became -1, यहाँ पे became 3, so यहाँ पे became 2, यहाँ पे became 3, यहाँ पे became 4, 5. Yeah, so it's better off if we just make a struct for that, because I don't want to like do this again and again, right? Like I think that's much better in that case. But because this is not like in Python, there's some struct. I think in Python there's something like definitely something like type def struct of heap, and you can I think it is something like void star elements and int length or something like that. I think so. And here will be, I think, something like this, and then you can like typecast this into whatever that is, because this method is very tedious on its own, to be very much honest. Even though I'm able to make it work, it is very tedious, right? I guess I'll end it over here. I will then, now, I think now I will go and, I think now I might as well do a few, actually, I'm gonna now do some LeetCode questions. So yeah, let's go. Okay, now we'll be doing uh, some LeetCode. So this was some boilerplate code that creates the binary tree for me given values. You can see I use this over here. So where was this? Yeah, given this array, it's able to create a tree. As you can see, this is it's able to create a tree, which is very fantastic. I don't know how it's able to do it, but hooray! Okay, let's try to solve some questions. So I've done few of them. Let's do validate binary search tree. Try to solve it. See what. Let's reload. I said let's give ourselves 20 minutes to do this, and let's see. Let's go. Given the root of a binary, it determines if it is a valid binary search tree. So valid binary search tree is quite simple. The way it is worked is by doing an X carry draw. It pretty much states for every subtree the left child will be less than the root and the right child. Assuming all elements are unique, right? The left subtree of the tree contains only specifically less than as you see, यहाँ पे there's 6, that's some 3. Right side now always will be greater, like 4 is there. Achha, so how do we do this? I think this is gonna be a recursive algorithm, right? So let's kind of think of the base cases over here, try to build something, right? So if I have if I think this thing like this, if I have root is none, then obviously it's gonna be true, right? If my root is none, then it's gonna be true, right? Like an empty tree will always be a perfectly binary search tree, right? If I'm correct. Else we'll just return false. I know this is very much lukewarm, but I just want to see if this passes any test case at the moment. It won't, it will fail most of them, but as you see this is just um, luck. Anyhow, right. Then it could be the case if root is not none. Root is not none. It can also be the case key if root is not none and root dot root dot left is none. and root dot right is none, then I can also say true in that case as well, right? Because that means a one there's only one element inside this. The root is none, dot left is not none, right? That is one thing. No, if it comes still over here, that means we know that root is not none. So root is not none, left is none, and the right is none. Whatever. Right now, if root dot left is not none and root dot right is none, right? If dot left root dot left dot valve is less than root dot valve, then we return true, else we return um, else we just return right. Right. Um, if root dot right is not none and root dot left is none, why is it like that? I is not important. If root dot right dot valve is greater than root dot valve, also over here this will be root. If it's greater than that, we'll return true, else we'll return false. Return false. Because this does pretty much bare minimum of this base case checking for us at the moment, right? Now apart from this, then we come into territory where either one of them is not none. So the way I want to do this is I want to say something like else you want to return what? Um, root dot left dot valve is less than root dot valve, and this is less than root dot right dot valve, and then I'm gonna do recursively, right? So the thing is this. Okay, I have compared this and this. Now I want to come over here. I mean, the way I do this, self is valid est. I'll say root dot left, and self dot is valid est dot right. That kind of makes sense, but I already see what the problem is with this algorithm. If I actually run and submit this, it passes. But the issue with this algorithm is it checks if root is none, true. If no child, right, it passes this. Is root dot left is not none, right dot right is none, right? And then it checks this. The thing is, the moment we come over here, we'll check, okay, no child, it comes in range. Actually, this won't come in range, but I think the way to think about this is something. So I have 5, 3, and okay, I think this might work. अच्छा मुझे पता था क्या होने वाला, तो 5 4 6, okay, 5 4 6 null null 3 7. अच्छा, actually let me just make this a much better way. 5 4 6 null null 3 and 7. अच्छा, इसका मैंने आउटपुट दिया टॉल एक्सपेक्टेड फॉल्स था. Why is this? So if we just only check this tree, so again this will not even come in any one of them, right? यहाँ पे check करेगा root dot left dot valve is less than equal to root dot valve is less dot right dot valve. So this shouldn't even pass. 4 less than 5. Oh, this is right, this is right, this is right. This works. And then it comes over to this. It says true, true. Then it comes over here. Again, here's the funny thing, right? It still works. But यहाँ पे 3 comes, which is an issue because now it comes on the right subtree of 5 and it has to be greater than 5. But due to the way our algorithm is states, this will still come true and like 2 sub true here. This only checks for that level subtree. यहाँ से this is correct. But this 3 is picking. So how do we fix this solution? Hmm. Yeah, same thing over here, right? If we do 1 5 4, this works for this, right? If I do 4 3 6, this works, but here is the issue again, right? How do I do that? Acha. Um, Acha, how do we solve this? Because this is an issue. Because as a whole, hmm, sure. Hmm. How would I solve this? Dot left, dot right. Hmm. Um, so every element over here collectively has to be greater than 5. Every element over here has to be less than 5 collectively. I am thinking we need to have some point of the root. So the way I think about this is, so like is valid self comma root, um, bool, and this will contain val, right? So initially val should be what? Initially val. um Acha, 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 acha. I think what it means to say is acha, acha, acha. I think what it's like in order. Acha, acha, now I get it. In order traversal. If it's a bad side, it will be a sorted order, right? It will be like a sorted order essentially, right? So yeah, so you can do something like that. Yes, I think you can really do something like that. So something like this. In order traversal. Why am I not seeing things or is it? Okay. 1, 2, 3. Righty, righty. Acha, fine. Hmm. अच्छा ये डबल हो गया क्या इधर? 1, 3. So pretty much what we do over here is we have something like an in order traversal type shit. Um, mm, this, like this real quick. Actually, I'm not gonna do too much of that. Right. Yeah. If my reason that is that. Uh, sure. uh, how to check if list is sorted in Python or not. I can check something like this, which has something like that. So I can say elements is equal to sorted. So let's run this. Uh, hmm. S- okay, so hmm, yeah. Uh, Hi. Did you mean what? Oh, hi. Calling itself. My bad. My bad. Chat. My bad. Guys, come on. Okay, let's submit. I think yeah. Now this is right. This is pretty much what? Uh, Crazy. So we got two, 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 two. Expected false output true. Strictly cha, 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 development of elements. Right. If elements I is less than elements I plus one. If this is not the case, return false except return. Achha, finally. Yeah, so this was not the brightest solution I've given, but the idea being is that if right, so this what is the time complexity of this? So uh, O of n, O of n, O of 2n. So it's O of 2n, and that's O of n. So yeah, that is our valid solution. We can just get the in-order traversal and check if the in-order traversal is sorted or not. But I want to see what is the actual solution given by this BFS. I'm interesting. How do you do this in BFS? Let's see.
Hey everyone, welcome back and let's write some more neat code today. Hey everyone, welcome back and let's write some more neat code today. Solving validate binary search. A very good question for practicing binary search tree questions. We're just given a root of a binary search tree and we just want to determine is it a valid binary search tree or not. And from learning data structures and algorithms, you might know that a valid binary search tree is such that we have a node like 2 and every single node in the left subtree 1 and if it possibly had other children is going to be less than 2, right? So 1 is going to be less than 2. And similarly, every single value in the right subtree 3 including 3's potential children's if it had any are going to be greater than 2, not greater or equal, strictly greater. And we know this is a recursive definition, so if we had 3 and it had some children, like 5 and maybe 4 over here, we see that it's not a binary search tree because 4 should be less than 3. 4 should be less than 3, but it's not. So this is not a binary search tree. So we need to do a recursive depth first search to solve this problem, but let me show you what you might try. You might just try a simple solution like, hey, 5. We have 5 as the root. Let's check its child. Okay, 3 is less than 5. That's good. Okay, let's check the right child. Okay, 7 is 7 because we see 3, it doesn't have any children. That's good for us. We don't have to check anything. But 7 has a left child. It has 4 as a left child. Well, that's good. 4 is less than 7. And it has a right child, 8. That's good. 8 is greater than 7. So is this a binary search tree? The answer
Is no, and that is a solution that I came up with. But the thing is, you forget about 4. You only consider that subtree at a given moment.
no, because it's really easy to miss. We have a 5 as the root. We have a
Exactly. So
right subtree over here,
how do I
and
remember
we have
that?
a 4
Right.
in the
How
right
do I remember that?
subtree. But we know 5 is not less than 4. That's not true. So we need a better algorithm, and it requires depth first search. We can't just check the neighbors. So our
Uh,
brute force approach would be for 5, check every value in its left subtree, make sure that its every value is less than 5, and then check every value in the right subtree, make sure 5 is less than every value in the right subtree. And so we would need n comparisons to do that, right? O of n. And then we'd have to repeat that process for every subtree. So 7, we got to repeat that, compare it to every potential descendant of itself, which is going to be O of n, and the time complexity of that overall is going to be O n squared. So can we do better than O of n squared? So one thing to notice is the root value can be any value, right? There's no restrictions on what the value can be because it doesn't have any parents. So we can say that it can be any value between negative infinity and positive infinity. And as long as that's the case, 5 is okay. We don't have to make any other comparisons. 5 is between negative infinity and positive infinity. Okay, and then when we go down to the left subtree, we know 5 is good. We don't even have to check it anymore. But when we go down to the left subtree, what do we have to check? All we have to check is that 3 is less than 5. So in other words, we just want to make sure 3 is greater than a negative infinity, which of course it is, and we're adding one more condition. We want to make sure it's less than 5. So our left boundary stayed the same, but we had to update our right boundary from up here, right? And so we're done with that. And of course, we don't have any children for 3 and 5. Of course, we don't have any children for 3, so we are done checking 3. Next, we want to also determine that the right subtree is a binary search tree. So we want to make sure 7 is greater than 5. But is there an upper boundary for 7? Like this could have been 100 or it could have been anything. So there's no upper boundary yet. So we just need to check that 7 is less than infinity, meaning that this is the right boundary, and it's greater than 5. So we had to update the left boundary over here. When we went here, we only had to update the right boundary. And this condition is true, so we are done checking 7. It is satisfied. And when we go to the right child, 8, we're going to do the same thing. We only have to update the left boundary, so we have to make sure that 8 is at least greater than 7, but it could be anything, so it's less than infinity. So that's good. 8 is a binary search tree, but now we get to the value that actually breaks our binary search tree, and let's see what our algorithm does. So we know since 4 is the left child of 7, it should be less than 7. 4 is less than 7. We have to update the right boundary for 4, but the left boundary stays the same. So we're getting the left boundary from over here. We're borrowing it from its parent because if 7 is greater than 5, then its left child, and 4 is a part of the subtree, 4 must also be greater than
then
5.
5.
So the left boundary is 5. Now, does this condition hold? It does not. 4 is not between 7 and 5. So this value breaks our binary search tree. So therefore, this is not a binary search tree. It's false. We're returning false. And with this algorithm, since for each node, all we're really doing is making a comparison, we're we're making a single, or rather two comparisons, this is going to be big O of n, or 2n, which we know is still linear. So we can just call it big O of n.
Yeah,
So
I would say a better solution. I mean, this solution is not bad by any means. It's elegant, I would say. But I'd say a better solution to this would be just the wouldn't a better solution would just be the one I did. Just find the inverted traversal and check if the inverted traversal is actually in ascending order, and yeah, then just boom shakalaka boom, right? Pretty much that. Let me just copy this entire thing from here to here. So how does that happen? Anyhow, let's run that. Let's see this works. Format this, submit. Cool. GG's. I mean,
now it's actually time to write the algorithm. Root value could be is no, because it's really easy to miss. We have a 5 at
interesting. He sets multiple things. Acha, these things are interesting. Mm, the thing I really suffer with most of the time is just not getting enough time to do these questions quickly. Stack is fine, I would say. Binary search is fine. Sliding window is something that I just. The sliding window, I like this. These things are just done for me. Linked list are fine. Kth smallest in a BST. Order binary tree. How is that easy? Like, how is that supposed to be? Kth smallest. Guys, don't even tell me what to do. What I am thinking is let's just go pure traversal, boom shakalaka, let's go K there. Crazy. Just heaps over here. Hmm.
as the root. We have a right subtree over here, and we have a 4 in the right subtree. But we know 5 is not less than 4.
I feel like it's a bit. This happens when you're not consistent. Anyhow, but I'm gonna take a break for. Yeah, I just need to wash my eyes. It's hurting.